Dr Bbosa Science, Kwano Kabeti Science, Love ya Bbosa Science, Truth na Beta, Truth na Omega, Truth na Alpha Science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Dr Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. At A-level, we teach sciences only. At O-level, we teach arts and sciences. Today, we are going to study transition elements one by one. In the previous lesson, we looked at general properties of transition elements. In this lesson, we are going to look at specific properties of a given transition element, starting from the first one, scandium. It's the first element in the first transition series. Apart from having partially filled d orbital, it has no other property as a transition element. In its compounds, it shows oxidation state, positive free. Its compounds are white. Actually, most of the chemistry of scandium is similar to that of aluminium. Because both have got oxidation state, positive free, they both form white compounds. They both form double salts, such as potassium aluminium sulfate or potassium scandium sulfate. The second element is titanium. Electronic configuration is argon 3s2 3d2. Properties as a transition element. Titanium has variable oxidation states, that is positive 2 and positive 4. B. Titanium has catalytic properties. For example, titanium 4 chloride is a catalyst in polymerization of ethene to polyethene. Important compounds of titanium. Titanium 4 oxide is used as a white pigment in soaps and paints. It is mined as titanium 4 oxide, so you get it as that. Titanium 4 chloride is used as a catalyst in the polymerization of ethene. You have already seen this. It is prepared by reacting titanium and chlorine. So titanium, which is a solid plus 2 chlorine 2 gas, you will get titanium 4 chloride, which is a volatile liquid. Titanium 4 chloride hydrolyzed in water to give titanium 4 oxide. So titanium 4 chloride liquid plus water, it hydrolyzes to give titanium dioxide solid plus HCl. The third element is vanadium, capital V. Electronic configuration is argon 3s2 3d 3. Characteristics as a transition element. A. Forms colored compounds For example, vanadium pentoxide is yellow. B, it has variable oxidation states. Vanadium forms compounds with oxidation state positive 2, positive 3, positive 4, positive 5. There's even a possibility that it forms compounds in oxidation states. It has catalytic properties. For example, vanadium pentoxide catalyzes conversion of sulfur dioxide to sulfur trioxide in contact process. Then D forms complexes. For example, that one. Important compounds of vanadium. Vanadium pentoxide is a catalyst in the conversion of sulfur dioxide to sulfur trioxide in the contact process during the synthesis of sulfuric acid. Sulfuric acid is one of the major chemicals in developed countries. The fourth element is chromium. Electronic configuration is argon 3d5 4s1. It is important to note that instead of writing 3d4 4s2, the electronic configuration is 3d5 4s1 because half full d orbital is more stable than less than half full d orbital. So there's the rearrangement in the electronic configuration of chromium. And is one of the questions they will ask you, write the electronic configuration of chromium to see whether you write 5 or 4 here. Properties of chromium as a transition elements. A, it forms cardiac compounds. For example, chromium-free compounds are green. B, it has variable oxidation states, positive 2, positive 3, positive 4, positive 5, and positive 6. C, forms complexes. For example, hexamine, chromium-free iron. D, it has catalytic properties. For example, a mixture of chromium-free oxide and zinc oxide will catalyze formation of methanol from carbon monoxide and hydrogen. Carbon monoxide plus hydrogen will get methane. You will get methane. Oxidation states. Chromium has oxidation states of positive 6 compounds. So in the positive 6 oxidation states are oxidizing. Positive 3 are stable, and the compounds in the positive 2 are reducing. They are reducing agents. Reaction with common substances. A, reaction with air. Chromium is extremely stable in air and is not affected by moist air. Probably is due to a protective oxide layer. It reacts with oxygen at about 2000 degrees with a brilliant flame to form chromium-free oxide. So chromium plus oxygen, you get chromium-free oxide. If we are using a Bunsen burner like we have in the lab, the temperature may not reach 2000 degrees. So you may even say that chromium doesn't react with air. Reaction with water. Chromium doesn't react with cold water, but at really hot, it reacts with steam to form chromium-free oxide. So chromium 2 solid plus water, steam is in gaseous form. It will give you chromium free oxide solid plus free hydrogen gas. Reaction with halogens, fluorine and chlorine combine with hot metal to give chromium free halides. Chromium plus fluorine will give you chromium free fluoride, or chromium plus chlorine will give you chromium free chloride. Chromium reacts directly with fluorine at 400 degrees Celsius and 200 atmosphere to form chromium 6 fluoride. Chromium plus fluorine will give you chromium 6 fluoride, which is yellow. Reaction with alkalis. Chromium does not react with alkalis at ordinary temperature. E. Reaction with ammonia or nitrogen. It forms nitride. Chromium plus ammonia will give you chromium nitride plus hydrogen. Then chromium plus nitrogen gas will give you chromium nitride. F. Reaction with acids. In absence of air, hydrochloric acid and dilute sulfuric acid react to form chromium 2 solids. Chromium plus an acid, you get chromium 2 solids plus hydrogen. 2. Reaction with nitric acid. Chromium does not react with nitric acid due to formation of a protective oxide layer. Important compounds in oxidation state. 6. Sodium and potassium chromates. 6 are yellow solids that dissolve in water to give yellow solutions. B. Silver chromate 6 is red. C. Sodium and potassium dichromates are orange solids that dissolve in water to give orange solutions. Chromates 6 in acidic solutions are converted to orange dichromates. So chromate plus an acid, you get dichromate plus water. While dichromates in alkaline conditions change to yellow, chromate 6. Dichromate plus hydroxide ions will give you chromate 6 plus water. So this is a common question. The question may be, state what is observed when an acid is added to sodium chromate 6 solution followed by excess sodium hydroxide. Then you could see that when you add it to chromate 6, which is a yellow solution, will turn to orange solution. When you add sodium hydroxide to orange solution, it will turn to a yellow solution. So the observation will be a yellow solution turns orange, and then on addition of sodium hydroxide, an orange solution turns yellow. You may be required to write the accompanying equations. Actually, an explanation in organic chemistry requires an equation if necessary. It cannot be avoided. Whenever you explain anything in organic chemistry, make sure you follow it with an equation. It must be a balanced equation with correct status symbols. Uses of chromates and dichromates. 1. To test for reducing gases such as sulfur dioxide and hydrogen sulfide. When a filter paper dipped in a solution of sodium chromate or potassium dichromate is exposed to a reducing gas, the color will change from either yellow for chromates or orange for dichromates to green. So the dichromate, which is yellow, will be reduced to chromium-free compounds that are green. 2. Potassium dichromate is used in volumetric analysis to estimate reducing agents such as iron. Potassium dichromate plus iron 2 salts will give you chromium-free salts plus iron-free salts plus water. Potassium dichromate and iron will react in ratio 1:6. Note that in a volumetric analysis using potassium dichromate, HCl may be used as an acid because dichromates are not strong enough to oxidize chloride ions like potassium permanganate 7 does. 2. Potassium dichromate is preferred in volumetric analysis because sodium dichromate is hygroscopic, cannot be weighed easily. Reaction of chromates and dichromates with hydrogen peroxide. In a dilute acidified solution, they react with the hydrogen peroxide to give a blue chromium peroxide. Dichromate plus hydrogen peroxide in presence of an acid will give you a blue solution of chromium peroxide. This is usually a temporary blue and serves to confirm compounds that contain chromium ions. Potassium chromate and dichromate form yellow precipitate with lead and barium ions. So barium ion plus chromate, you get barium chromate. Lead salt plus potassium dichromate will give you lead chromate. Potassium chromate and the potassium dichromate can thus be used to test for presence of lead or barium ions. The yellow precipitate of lead chromate can be distinguished from that of barium chromate because it is soluble in sodium hydroxide. If we are to test for lead ions or barium ions using potassium chromate, then we have to follow it with sodium hydroxide. When you get LPPT insoluble in sodium hydroxide, then that is barium. When you get LPPT soluble in sodium hydroxide, then that is lead ions. Chromium-free compounds. A. Chromium-free chloride hexahydrate. This is particularly important because it shows isomerism in inorganic chemistry. It is one of the common compounds that can exhibit isomerism in inorganic chemistry. The first isomer is chromium, which is green. The second isomer, water, 5 water and chlorine are ligands. Then quad ions are not. Quad ions are not. That's light green. The third isomers, 4 water and 2 quad ions are ligands. then 1 chloride ion is free to ionize in the water. Distinguishing between the isomers: A, when titrated with silver nitrate solution, the number of moles precipitated per mole of chromium free chloride hexahydrate are. This complex will precipitate free chloride ion, showing that the free chloride ions are free to ionize. The water is bound. In this one, will precipitate 2, showing that one of the chloride ion is used to form the complex. Then this one will precipitate 1 mole of chloride ion, showing that the 2 of the free chloride ion are used to form a complex. And only 1 chloride ion is free to ionize and form a precipitate with silver nitrate. 2, when we use electrical method, we shall find that this compound here has got 4 conducting ions. This one has got 3 conducting ions, while this one has got 2 conducting ions. So this one will ionize to produce 2 ions. This one will ionize to produce 3 ions, while the first one will ionize to produce 4 ions. Of course, this is more conducting than this, because it contains very many conducting ions. We find that when we count the number of conducting ions, the first one will give you 4, the second one will give you 3, this one and 2 chloride ions, while the third one will give 2 conducting ions. Hydrolysis of chromium-free compound. They hydrolyze in solution to give acidic solution. Consequently, or following hydrolysis, the solutions of chromium-free salts will turn boiled mass paper red, because chromium-free salts will hydrolyze in solution to give acidic solutions. Then 2, solutions of chromium-free salts will liberate carbon dioxide from carbonates. So chromium plus carbonates plus water will get chromium carbonate, which is a green PPT, and then carbon dioxide. So in exam, you may be asked, state what is observed. Sodium carbonate is added to chromium-free salts, or chromium-free sulfate, or chromium-free chloride. You will get a green PPT and effervescence. The effervescence is due to liberation of carbon dioxide. The green PPT is due to formation of chromium hydroxide. The explanation is that chromium-free salts hydrolyze in water to give acidic solutions. The equation you have already seen. With sodium hydroxide, chromium-free salts will give you a green PPT soluble in excess. The green PPT is due to formation of chromium-free hydroxide, and this chromium-free hydroxide dissolves in excess sodium hydroxide to form a complex ion. With ammonia solution, chromium gives a green PPT insoluble in excess. So chromium plus hydroxide ion, you get chromium hydroxide. Confirmatory test: chromium-free forms green PPT soluble in sodium hydroxide. You have already seen that one. To form a green solution which turns yellow on addition of hydrogen peroxide, and finally temporarily blue on addition of sulfuric acid. In terms of equations, chromium plus hydroxide ions will give you chromium hydroxide, which is a green PPT. The green PPT will dissolve in excess sodium hydroxide to form a complex ion. Then a complex ion will be oxidized by hydrogen peroxide to a chromate ion, which is a yellow solution. Then the yellow solution plus the acid plus hydrogen peroxide will be oxidized to chromium peroxide, which is a temporary blue. So this is yellow, this one is blue. So we confirm chromium by reacting a chromate or a dichromate with hydrogen peroxide, and we get a temporary blue. Thank you very much for listening.
Omukyala kyakufumbira kyolya, omukyala kyakufumbira kyolya, naye lwaki mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki wangana okulya mu kyalo, lwaki oza simalako olimba, olusi wogifumbira waba kulwaza, olusi wogifumbira waba wakyamu, omulungi atanabakanyiwa, n'obutayoza kiba kikyamu, entikko y'omukwano kisenge, lwaki naye lwaki mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki wangana okulya mu kyalo, ofumba okwagala lisaaki okunyuma, wange nsiba mu lisaaki, mondo okumukutandwawo, mondo okumunyima ntabuka, mondo okumuzima kuba, mondo okuwomerwa kiva ku mazzi, wetegekere muno, mufunira akaseera akamala, ozanyisa omutwe ogwanyumirwa, wagazanyisa mipiira nyumisa, zanyisa baluni, zanyisa amabeere, lusinyoka n'okuyonka anyumirwe, faayo faayo. Omukwano gwagala kuyiya, ofumba ogwagala lisaaki okunyuma, wange nsiba mu lisaaki, bwe luba oluganda nsobola okuwasa omukyala abawuwo, njagala omukyala abaawo, betita yombayomba, betita nyiganyiga, betita ganagana, bw'oyagala akawunga abaawo, bw'oyagala omuceere abaawo, ennyimba z'omupiira asobola, anyumisa, nyumirwa omukwano gwe, mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki mono ku moto womala kuyomba.